So let us discuss solution to quiz 3. So let us start with the very first question. It says that okay, I have vector v and vector w. I have to compute v cross w using the algebraic formula. So I know that the cross product between two vectors is defined to be determinant of this matrix, where the first row is ijk components. The second row comes from the components, the coefficient of these components of vector v, which is 2, -1, 3, and then the last one is coming from w, which is -1, 4, 2. To compute the determinant, you know that I have this I. The first one I delete row and column. Then the leftover I'm going to write in a 2 by 2 matrix. -1, 3, 4, 2. Then the next one should be -j, and then I have determinant. Then +k, I have determinant. So now I'm going to delete first row and second column. Then whatever left over is, I have 2, 3, -1, 2. For the final option, I'm just deleting the last column in the first row. I'll get 2, -1, -1, 4. So this one is I hit, and you know I multiply in this way, so -2 minus 12. -j hit, I do this 2 times 2 is 4 minus -3, which becomes +3, and this one is 2 times 4 is 8 minus -1 times -1 is +1. So this is -14 I hit and -7 j hit +7 k hit. Okay, so this is the cross product, and now I want to compute the magnitude of this cross product. So the magnitude thing is equal to square root of the first component squared, which is -14 squared plus -7 squared plus 7 squared, which is root. Now what is 14 squared and 7 squared, 7 squared? So I can do something here. What should I do? Yeah, there are a couple of things to be done here, but the first one can be written as 14 squared, 7 squared plus 7 squared. And for simplification, I'm writing the first one to be 2 times 7. So 2 squared, 7 squared plus 7 squared, 7 squared. I can take 7 squared out. Then I have 2 squared plus 1 plus 1. Then square root of 7 squared is 7. Then I have a square root of 6, because 2 squared plus 1 plus 1 is 6. Yeah, this is answer. If you don't want to do this thing, it's all okay. You just like maybe leave it here, that's fine. Okay, the second question is, I'm given two vectors. I need to justify that why these vectors, like, are these vectors parallel. So I have to find maybe a number, a constant k, such that if I'm going to write a is equal to k times b, or b is equal to k times a, then these vectors are called parallel. And you can see, like, if I like my a vector is equal to 1/2 of vector b, and so this is the number. You can see a is I plus 2j minus k, and 1/2 of b is 2i plus 4j minus 2k. So this is again like this, half of this is equal to I plus 2j minus k. So you can see like these two things are equal. It means a is equal to half of b, so a and b are parallel. It implies vector a is parallel to vector b. Now second question just follows from the first one because we have to find the cross product without computing, and we know that the definition of cross product is, the geometric definition is this one, sine of theta, and this is normal vector in the direction of the cross product, which is like, you know, that it comes from right hand rule. Now since these are parallel, the angle between these is 0. So if I put 0 here, the cross product that I get for these two vectors is 0 vector. I don't need to compute anything because they are parallel. Third question is pretty simple. So we have to use cross products to simplify these expressions. Like first expression is really simple. We know that W cross V is same as negative of V cross W. And then I have positive V cross W. One quantity is positive, another quantity is negative. I can cancel out these and I simply get a 0 vector. Similarly, I can simplify these things. This thing can be written as 3 times 2 V cross W. Yeah, I don't remember this identity, but I think this is true. This is true. So this becomes 6 V cross W. Okay. So there's not a good simplification in this problem, but it's all okay. And this one is we can write V cross V. Like we can take the cross product with the first one, then the second one, V cross W. Now we know that the cross product of a vector with itself is always a 0 vector. V cross W. So we get only V cross W. This is the answer. Okay. So the next thing is we have to find the volume of the parallel piped. So first of all, we are going to compute what is A cross B. So this is vector A, this is vector B. A cross B would be, again, determinant ijk, and then 1 1 1 coming from A, 2 minus 1 0 coming from B. So I'm not doing everything here, I'm just writing my answer. It should be 0 plus 1. Like now you know how can I compute these things, so you can do by yourself. This is 0 minus 2 and plus k hat will be negative 1 negative 2. So this becomes only I hat. What is this thing? This is 2, I think. Yeah. So this is plus 2j hat minus 3 k hat. This is the vector. Then I have to find the volume of this parallel piped, and there was a formula that I showed you in class, but you can also do that. Okay, you take this cross product and take its dot product with C and then take its absolute value. This gives us volume. So A cross B is I plus 2j minus 3k dotted with C, and vector C is this one. This is I plus 0j minus 2k, and then take its absolute value. So this becomes 1 times 1 plus 2 times 0 plus minus 3 times minus 2. So this is 1 plus 0 plus 6, which is absolute of 7, which is 7 because this is a positive number, so nothing changes. Okay, so this was the volume of the parallel pipe. The last question is like we are going to complete the proof of this algebraic definition of cross product. So the idea is if I have a vector V and I have a vector W, for example, so this is V, this is W, then this vector is the vector V cross W, and it is always perpendicular to both of these vectors. So like if this is vector V and this is vector coming from V cross W, then we know that like if they are perpendicular, the dot product between these two should be 0. it means this quantity should be equal to 0. Similarly, if we consider, okay, use orthogonality. Now this is another thing, if we use this orthogonality, that v cross w is also orthogonal to w. So this is v cross w and this is w. They are orthogonal. Then this thing again should be 0. The dot product between these two vectors should be 0. Now, what is the choice of A, B, and C that makes this thing 0? So that makes this thing 0. So now let us try to find what the choice should be. So if we are choosing A to be this one, if I multiply A with W1, as you can see, then this will be W1 V2 W3 minus W1 V3 W2. This is the first term, and then C should be this one whose dot product is W3. So this is like V1 W2 W3 minus V2 W1 W3. Now I need to write something here so that I can cancel out the things. So you can see, like here, this guy cancels this one, and I cannot cancel these two. To cancel these two, I need to have something here, and that thing should be negative V1 W2 W3 and then positive W1 V3 W2. So like to make this thing 0, we want these things, like this is positive, this is negative, they cancel each other, this is positive, this is negative, they cancel each other. So the definition of B should be W1 V3 W2 minus V1 W2 W3. Okay, again, like you can check for any typos or anything else. So this is the same thing here. The component wise formula of the cross product should be okay, sorry. So this thing should be there, but this is multiplied by W, so I'm just removing W2 from here because W2 is already there. So this definition should be W1 V3 minus V1 W3. Okay, so this was the third quiz, which was not too long, to be honest. Okay.